Hey there, folks, and welcome to another special episode in our interview series. Today, we are joined by Dennis Feeney, who is senior geologist at the Idaho Geological Survey. This is actually Dennis and I's first time meeting, like face to face. But the interesting connection here is while we're both in the same state, I know Dennis by way of his wife Chelsea, who worked with me and some of my colleagues on the, I guess I could show the book here, the little Roadside Geology of Idaho book. She's not only a geologist, she's the graphic designer and made all the fabulous maps in that book and so many others in that series. But I knew her husband worked for the Idaho Geologic Survey. He and I have traded emails over the years, and I thought he would be just a fun guest to have on, learn more about his background, find out more about what he does. He's mainly, I think, tasked with geologic mapping, and so we can share some insights from him onto exactly what that looks like. So thanks for joining us, Dennis. Appreciate it.
Oh, thanks for having me here, Shawn. It's really great.
Awesome. Well, let's just start with, I like to start with just kind of where people grew up, their backgrounds, and then how you got into science and geology. Just kind of walk us through those early years in the Dennis Feeney life story.
Sure. So I grew up in Casper, Wyoming. In terms of Wyoming, it's the big city. It's 46,000 people, right in the center of the state, and it was a boom town. So it had its fair share of oil and gas development in the 60s and 70s that sort of gave it that population growth. But it was a great town to grow up in. There was mountain in the backyard. Turns out there was rocks and geology all around. But I was just a regular old-fashioned kid running around the streets and the hills and the mountains, making mayhem wherever I could. But it wasn't too much trouble. And then, so my best friend's dad was a geologist, and he would ride those boom and bust cycles. So sometimes he was in the oil fields, and then sometimes for a few years he was a middle school teacher for us. So I had Mr. Reddy around for everything. He was this old, well, no, he had this big gray beard, and he talked with a very deep and solemn voice, and he had these gray eyes, and we'd take road trips, and we'd be sitting in the back of the vehicle, and he'd be droning on. If you look out over the windows there, you'll see the Eocene formations that represent volcanic eruptions that happened in the Absaroka Mountains, 180 miles to the northwest.
Right.
He would be boring the daylights out of us, and but I always wondered if some of that sunk in. So we drive up to Thermopolis, and we'd go through the Wind River Canyon, where you pass through, I think it's Precambrian all the way up to Mesozoic rocks, and you see the sequence, you see some faults, you see tons of beds and tons of formations. It's such a beautiful drive, and I used to just love to make that drive, and yeah, having a geologist speak at you, because it wasn't really interactive at that point. It was just
Right.
speaking at us.
It's like a lecture,
And
yeah, like a book on tape or something.
yes, exactly. And he was great. So I went to college at the University of Wyoming, and I started off in engineering. And I just didn't like it. It was a little boring. So I started walking around the university going, I want to keep doing sciences. I like the sciences, but I needed a science that put me in the outside. So they told me you can go to forestry, or you can go to geology. And I went over to the geology department, and those professors were awesome. They were so cool. They were great people, really enthusiastic about what they did. And I was in like a geology 101 course. So I just figured, well, this suits. Let's do it. And I liked geology. It was good enough. I was enjoying the classes I was taking, and the things I was learning were really interesting. But it really didn't click for me until field camp. So for those people who don't know, geology field camp is sort of a capstone course that happens at the last year or last 2 years after you've had most of your sedimentary classes, and you have your metamorphic and your igneous classes, and you sure want structure before you go into field camp. So at Wyoming, that is a really great one that just traveled all around the region. So I've been down in New Mexico and Utah and Colorado and all stretches of Wyoming. And that's where it all clicked for me. I was like, are there jobs? People doing this still?
Right. So you were just excited to be out like hiking and figuring out the puzzle of the earth and putting it on paper and then just trying to figure out like, okay, if this is like a viable career, can you actually like call this a career, right?
Yeah, and they didn't give me a lot of enthusiasm for there being a career in this. The Wyoming State Geological Survey is in the University of Wyoming, and there were definitely people mapping there, but they didn't necessarily encourage it as like, yeah, there's a ton of people mapping and it's great work. So I, went through field camp and thought, well, this is cool, but maybe I'm not going to do it. So after graduation, I went and did a couple years of. I was a cross-country skier in college.
Okay.
So I raced semi-professionally for a team in Oregon and did that for a couple years, and then said, okay, maybe I'll go back to grad school. The skill set was there, and I went to Western Washington University in Bellingham, Washington. And I chose that school because again, the faculty was fantastic, just a really enthusiastic group, and they didn't have PhD program. So I thought I wanted to go to a school that was sort of a teaching school where the faculty was interested, faculty was good, but part of their initiative is to get those grad students and keep them moving.
Yeah, do you feel like, sorry to interrupt, but I mean, I have a similar background where I somewhat intentionally chose a master's only grad school, knowing that I would be, sort of top dog and I would get the opportunities and the attention from the professors versus going to a much bigger school that had a PhD program. So it sounds like you were maybe a little bit deliberate making that choice as well.
Yes, I don't think I was. I probably wasn't tuned up then for research. I just sort of thought, well, I'd like to go continue my education, and I didn't really much understand what research was. So I figured if I went to a bigger school, a UW, an R1 school, I'd just get lost. I'd probably finish the degree, but I may not have the support that I probably needed at the time.
Right.
And I applied to a couple other relatively small schools, but I'm really happy with having gone to Western.
Yeah. And you picked, what was your like project that you worked on there? What was your like thesis and what was your main emphasis there?
Well, so, I kind of walked in saying, I don't really know what I'd like to do, but I kind of want to be outside. And I kind of like just asking questions, maybe solving riddles as they come along. And I worked with Scott Linneman, who's recently retired.
I've heard of him. Yeah. Yeah. He was a great educator. Yeah.
Great educator. And he taught for a little bit down here in Lewiston, Idaho at the LCSC. So there's that small Idaho, or small geologic world. You start running into these people in all sorts of places. Right. So I worked with him, and he found a project that Wes Hildreth had suggested, which was looking at the lake sediments that formed in a caldera at the top, not the top, but up on the flanks of Mount Baker. So Mount Baker had 3 phases. There was the early Hannigan caldera at 2.2 million years. Then you have the Colshan caldera at 1 million years. And then around 600,000, you start the mountain building phase of building Mount Baker, part of the Cascade Volcanics. So that 1 million phase had this lake in the center that recorded some sedimentation and some environmental history. So I hiked 5 miles in from Artist Point up there, and just beautiful terrain, beautiful country. So it's sandwiched in between Mount Shuckson and Mount Baker. So big glaciers, big mountains.
Yeah, the high Cascades.
There was a pack of mountain goats that would traverse from one side of this valley that I was in to the other side. And you could sort of tell that they were resting and napping and spending a lot of their free time in the sedimentary rocks because they were looser, freer, easier to break apart, and a little more comfortable for hanging out in.
They had it figured out already for you.
They did. I just follow the goat tracks. Yeah. So I did that thesis there. You looked at some dating, did some paleomag work, sort of recorded the environmental history. It was a great story to tell. Part of the problem I would suggest was that it didn't have a lot of relevance to why this is important, or
Right.
how does this tie into greater cascade systems. So, I didn't really push it hard to get published. I probably could have tried a little harder, I guess,
Yeah.
on that front. But again, I think that was part of my growing process. Was I am not a researcher. I wasn't a researcher at that time, and I had to figure out how to make my stuff relevant and why it's important. I think locally, it told a really fun story. That was pretty interesting, but sort of left me out a little bit there.
Yeah.
So I just enjoyed that project. Enjoyed going to school at Western Washington. Enjoyed the faculty I had there. They were so great and they were really helpful. And I still talk to a lot of them when I go to conferences.
Right.
Um,
No, it sounds like you had
so
a great experience there. I'm wondering, what would you consider, like, it doesn't sound like as you went to grad school, like I went through with a project in mind that was very structure oriented. So like in my coursework reflected that. So that that experience made me a structural geologist. Would you consider yourself more of like a said strat kind of geologist, or maybe just more of a general like field geologist out of that experience? Or where did you
yeah,
feel like your expertise laid at that point?
if I were to tell people I claim as a field geologist, I don't necessarily know that people look down on it, but it's like, great, you're not really good at anything but going out and camping.
Well, I mean, I think now in today's world, I think that's more a skill. Like maybe when you and I went to school, all of us were field geologists, but now I think it's a more rare skill set, I suppose. As more
Yeah,
people are more lab
so
oriented.
the project was really focused on StratSed. Then there was a volcanic component that dealt with sort of the interaction of these sediments and the volcanics, because this active volcano eruption, collapse caldera, there's still an active system of volcanism going on all around. So you're looking at peperites and flute structures from overburdened sills or flows on top. There was some pyroclastic material. So you're really it's still quite a bit of observational science, but
Right.
yeah, I just sort of was, and then there was a geophysical component in the sense that I took up probably 60 samples for paleo mag studies, which didn't turn out to produce anything, though ripped holes in my backpacks carrying these rocks 5 miles out.
Yeah.
Yeah, so I don't think I necessarily came away with a traditional structural geologist, geomorphologist.
Yeah, more of a jack of all trades, which is great. I mean, I think in
Yeah,
today's environment, you need a multiple, you need a lot of skill sets. You need to be able to dabble in a lot of geology.
and I think that actually applies really well to my work here at the survey because, yeah, that's one of the things you eventually will figure out, that you just have to be able to do everything.
Yeah.
When you're a mapping geologist, you don't get to a rock and go, I don't know what that is. I'll just leave it blank.
Right. Or wait, that's not my forte. I'll let someone else figure it out. So
Yeah,
you
yeah.
gotta get in there and figure it out. So
You got to
what?
give it a punt.
Yeah. So you end up graduating Western Washington, and then what were the next few years like for you? What was the next steps?
So after that, we moved to Montana because my wife wanted to do her master's. So she got into the University of Montana, and we moved to Missoula, and I had to find work. So I did a summer working as a well site geologist in the Bakken oil field. Worked with marathon drilling. We did 2 wells, took 28 days each well. We created these reports. We made these figures, and it just wasn't for me.
Well, sometimes you have to do something to realize it's what you don't want to do, right?
Yes, yeah. I think maybe if you were geosteering in sort of a wildcat environment, or if you were geosteering in maybe more complex geology, it could have been interesting. But the Bakken oil field is 9,000 feet down. Everything's flat. Maybe there's a fault here that offsets things 2 or 3 feet, but
Yeah. It's layered lake. Yeah.
yeah, it's pretty basic. And you don't get to actually drill through some of the fun stuff. They pull you in when they hit the lodgepole limestone, which is 2,000 feet thick, and you're like, well, this is going to be boring.
Yeah. So not enough diversity for you to really kind of intellectually stimulate you.
Yeah, it's that feeling of I like the paycheck and the work isn't horrible. It's not. It's just not stimulating. It wasn't that
Right.
much fun.
Right.
So I came back home and I found a company doing onshore geophysics. Sorry, offshore geophysics. So um, one of the guys had figured out that he lived in San Diego. Oh, one of the owners figured out he lived in San Diego doing geophysical mapping for offshore projects, and he didn't have to be in San Diego to do the work. You could do it anywhere, and he
Hmm.
went back to Montana where he was very happy. So we did offshore ocean floor mapping. So we were mapping telecommunication lines and oil platforms and uh, like there was a scientific node that they put out at the University of Washington and Oregon State University had a collaboration. It's the one that's monitoring the subsea volcanoes that are about to erupt.
Oh, okay. Yeah, yeah.
When they were putting those nodes or they were getting prepared, we wrote the desktop study that prepared for the
Right.
environmental impacts of how these things are going to be placed. So we would make these geologic maps. We made maps that went from Oregon to Japan
Wow.
because we're still laying telecommunication cables on the seafloor, and
You were mapping the seafloor. That's pretty cool. Like
it
what
was
what
pretty cool.
what kind of data sets are you using to like to put those maps together? I
So
mean,
largely they're geophysical. So you would use
okay. So it's
side scan sonar,
interpretation.
which is what a lot of fishermen use to find shoals of fish when they're out on the water. You can get the seafloor map with the side scan sonar, and then we'd use sub-bottom profiling, which is a device that all these things are towed behind a large boat, and this one sent a beam straight down, and that would bounce back off of different layers of the ocean floor, and you could map stratigraphy of the ocean floor, so you get your cross section that way.
Hmm.
And you could see faults, and you could see coral reefs, and you could see different changes in density of the material of the ocean floor. And then we'd use a magnetometer to help pick up things that we crossed, things that would help pick up things like we crossed, like you cross another telecommunication lines, you cross a sunken ship.
So you're making a map as you go across the ocean with a boat, but you're only going. So your maps are these little skinny, like, because transects basically, because you're only going from point A to point B. You're not
Yeah,
laterally moving out, so it's limited in terms of its, it's two dimensional or one dimensional, really, in a way.
yeah, it was one dimensional. We would try to make them three dimensional, so we'd end up with these sheets that are about 24 by 36, and they'd have three maps on it. You'd have the topography map that you've made, you'd have a geologic map that you've made, and then you'd have a cross section map that you would have interpreted as you cross this. Now, really, the most important thing is the first like 200 miles as you get to that continental shelf where everything drops off. Once it gets to that deep benthic environment, not
It's all
much
the
changes.
right. So that's where the most
So
diversity is in that continental shelf, continental slope region.
that's right. And
Okay.
then when they were collecting the data, they would be making these swaths, and depending on, so if they were setting, we did a lot of work in Trinidad and Tobago where if they were setting derricks up there to
Hmm.
drill first,
Yeah, offshore
we would
drilling.
help them position where their derricks should be set and where the pipeline that they're going to be connecting to the future goes. And you would run through corals and you'd try to have them adjust around some of the coral reefs. You would see. I remember one time we saw this zone, just a zone of maybe 100 feet wide, and you're getting the side scan sonar imagery back, and you go, "There's something happening in this zone, but we can't figure out what it is." You see sand up here, you see some sand over here, and you're like, "But it didn't take on the appearance of a shoal. It didn't take on the appearance of limestone or coral reef." And we're like, "What is this?" So the other thing we'd have them do is we'd have them pick grab samples. So your geotechnical grab sample, which is what you're using to verify your interpretations of sand, silt,
Yeah, getting the real
clay.
data. Yeah.
And we asked them to go back and resample this zone, and what they came back with was a Ziploc bag full of sand dollars.
Hmm.
And we were like, sand dollars. So then you start having to look up sand dollars and research about them, and you find out every year they have mating ritual, which is them coming up to this certain elevation of the shoreline. They all get together and they reproduce in this massive swath
Right.
all the way up and down the coast. And I was like, that's pretty amazing. That's a little bit of news that I hadn't thought of.
Right. But probably messed up your the grab sample wasn't representing the sea bottom like you were hoping to because it was covered by these sand dollars.
Yeah, well, again, hopefully in most cases the seafloor doesn't change that dramatically
Right.
and that quickly.
Yeah.
But I don't recall exactly what the elevation was or why they were specifically in that zone. But boy, they all knew where to go.
Yeah. Crazy.
Yeah, and then when I worked for that company, it was called Geomarine Tech. They had a lot of really smart guys who worked there, and we get a lot of data. So you'd be processing. I don't know if you've done any work with LiDAR, but you're processing. If in LiDAR you can process 10 million points, and we would do the same thing this was in 2005, 2006. Before you had Excel would only take 66,000 points at that time, so
Right.
you had to learn to break your files up to make manageable sizes to process some of the data.
Yeah, the data sets were huge. Yeah.
And these guys would, one guy would come up and say, "Hey, what's with these seafloor circles that we're seeing? You could see there's a rim attached to them. You could see this thing." And we'd all sit there and speculate and try to figure it out. And they love the idea of writing papers on some of the things that we're finding because there's no research available for them. So I worked with a company that had a good scientific pursuit. They were doing commercial work, but they also had an interest in the science aspect.
Right.
So let's see, that was 2008, and then I was laid off during that recession of 2008. So
Oh no.
home prices come in and collapse,
Casualty, yeah.
and everything goes down. And I think maybe I was there for 2 years, and I got laid off with the group. There was a few of us who were laid off. I think they still were able to keep up and go after some of the slow times. But so I was unemployed and I was looking for more work, and my wife, who's from Virginia, got a posting about jobs in Virginia. So we both applied to and took 1-year contracts at the it's called the Virginia Department of Geology and Mineral Resources, but it's basically the Virginia State Geological Survey. And I did, so I got to continue some of my work doing offshore mapping. So there's a city there called Virginia Beach, and they have large beachfront that is constantly being eroded by longshore drift. So all the sand they keep wanting to pile sand up here to make this beautiful sandy beach, and the sand doesn't want to stay there. It just goes down to North Carolina, just gets
Right.
carried on down.
Just longshore currents, yeah.
Yep. So they've been in a relationship with the Army Corps of Engineers, and they've been replenishing these beaches for ages just with sand shoals. So I went out there and helped them identify more sand shoals. And while I was there, I noted, there's always that issue of people wanting pristine white beaches, or
Yeah.
they want to think it's these California beaches. And I'm like, well,
Yeah.
you're coming off of the Appalachian Mountains, and these rocks are full of other minerals.
Yeah,
But it
they're
turns
not
out
white.
yeah, exactly. So it turns out all those dark-colored minerals are mostly heavy minerals. So there's actually an economic value to it. So there's a company called, it's an Australian company. I can't remember the name of it, but they had a small mining operation inshore that would sift these sands in a Franz separator and pull out the lightweight materials from the dark, or from the heavy materials.
Heavy,
So it's
right? Density sorting.
essentially a light dark separator in some ways. And they were using these heavy minerals, so it's monazite, ilmenite, titanite, and they would use them for paint coloration. So they had an economic value, and I was like, why doesn't the city sit there with Franz separators on the beach and pay a company to mine these sands, separate them out, and use it as an economic purse? You can offset some of your cost of having the beach replenishment going on
Right.
with some of these heavy sands. Never did happen.
Yeah. And if
It
they
wasn't
pull out
really
the heavy stuff, the beach gets lighter in color, doesn't it?
each
Probably over
lighter
time.
in color. They
Yeah.
make a little money on the side. It's a win-win.
Everyone wins. Yeah.
But of course, they're not going to do that. It's just one of these things. You come up with ideas and you go, "Wouldn't that be great?"
Yeah.
And there's a part of me that wishes I was more of an entrepreneur myself, and I'd go, "Well, I'll start doing this."
Yeah, exactly. Low hanging fruit there.
Yeah, yeah. So we took that job on for 1 year, and the Virginia survey was like, "Oh, we're keen to keeping you on, but sometimes life in the surveys can be a little tough, and it's sometimes you're contract based, and it's hard to establish a life 6 months or a year at a time, hoping that there's going to be a contract in another year to get
Yeah.
going."
Right.
So we both decided not to stay on for more than 1 year. We went back to Montana. And while we were there, both just working on, she was working for Mountain Press then, making the books, and I was working odd jobs. And we got pregnant. She got pregnant.
Right.
And
Another wrinkle. Yeah.
yeah, and then I realized, oh, I better find some work because I
Yeah.
can't
You got a family now. Yeah.
I can't just be fixing the house and being like, oh, look at me, I'm doing renovations. So I started applying for work, and Missoula was not great for jobs in terms of prospects. There's a lot of people there with a lot of degrees, and there was a lot of companies there willing to pay people very little for their degrees. So
Yeah.
I started looking around. I had an interview at the Lucky Friday mine, which is one of Hecla's mines in the Silver Valley of North Idaho.
Hmm.
And that would have been a production job, which is going in the mine for 6 hours, measuring all your progress, and then heading back to the top and remapping your progress, or remapping those days' progresses, so the next mapper can come in and figure out what's going on. And at the same time as applying for that job, I was applying for this job and got it, and have been here now for 12 years. So
Right.
we were able to build a life and some stability here in Moscow, Idaho, and have really enjoyed our time here since then. So that's how I got to the survey.
Right.
And I was always sort of chomping at the bit for one of these mapping jobs. It was always, since field camp, that's always been an idea. It was like,
Yeah. Well, they're pretty lucrative, I think, to just any field geologist is like, ooh, there's a job mapping. Like that would be something a lot of people would really try to go for. And like you said, there's very few of them, so it's quite the rare thing.
yeah. So in some ways, you'd think there's 50 states. Not all 50 states are mapping. Now 50 states have surveys, but let's say we're down to about 46 states with surveys, and then if they all have two mappers mapping, 2 to 3, you're at 100 to 150
Yeah,
jobs.
not a
And
lot.
then the USGS has got another probably 50 people who do mapping. So you're down to 200 people who do mapping. And that's one of the hard parts about the mapping is that you tell people, well, I do mapping. And especially, going to conferences, they all go, well, isn't the mapping done? I look behind you, the state map, it's done.
Right.
You guys figured it out.
What are you doing? You're not, yeah, there's nothing for you to do. Right.
Yeah, but then you realize that you gotta go explain to people that scale's what matters, and that scale is 1 to 750,000, and the mapping we do is 1 to 24,000. So you
Right.
got to get really in there and zoom. And I know from having looked at some of the roadside geology books, you go, oh, you can see where some of these people had projects because they want to describe the maps here in 1 to 24K scale.
Right.
But they're trying to get the bigger story across here.
Right. But they're
So,
tempted by going deep in the weeds there. Well,
right.
maybe talk, Dennis, about like what geologic mapping looks like, how it happens, like what I think we all get that you're going in the field, you're looking at rocks, but like maybe walk us through the whole process from like, okay, here's an area that needs to be mapped through the work to like the completion of like the finished product.
Yeah, sure. So what it starts with is finding like the need or the want or the desire. Why are we going here? And we actually have at the Idaho Geological Survey, we have an advisory committee who gets to put their input in as to where we're mapping and why we should be mapping. So I'm currently got a project in the Weiser Boise area, so Boise and then a little bit northwest of there. And that was drawn because that was selected as a project area because there was a new oil and gas field that basically just became economical. It's not, we've known about it for 100 years, but it was never economical. So in about 2012, 2010, gas prices went up, cost per oil went up. We started doing a lot more fracking, a lot more technologies got put into oil and gas, and it made this oil and gas field in western Idaho a little bit more economic. So when we can, we attempt to adjust what the survey is doing to meet the needs of the interest or the immediate concerns. Another good example is in 2017, 18, there was talk of critical minerals becoming important. There's a series of minerals and elements that we don't control the market on. The United States doesn't control the market on. So we need to identify where these minerals or where these elements are found in our earth. And Idaho's very rich in a lot of mineral resources. So things like cobalt or copper or just generally rare earths.
Platinum,
so we have to identify them, and we have to start maybe understanding where the resource is, why it's there, how big it is. And we've got some recent projects on cobalt, recent projects in copper. There was a copper discovery in western Idaho that's pretty large. And sort of understanding where that copper deposit came from and how possibly far widespread it might be. They're going to find it economically viable near the surface, and that's what they found in this Cuddy Mountain project. But are we going to find it at depth, and will depth become economically viable someday? We should be aware of this sort of stuff.
Right.
So we got that advisory group who tells us places that they should go, places we should be, things we should be looking for. We look for mineral development, mineral potential.
Hazards probably are a priority.
Hazards are one. Yeah. Human development. So we have roads. I always suggest that for every gold project and silver project and oil and gas project, there's an aggregate guy who's making a ton of money.
Right.
Aggregate's incredibly valuable because we use
sand and gravel.
Yeah. Exactly. So even identifying where these gravel pits have been. BLM has them, the Department of Transportation has them, but they lose them. They can't remember where they did it, or they can't remember who owns it, who was managing it. So we'll do a lot of that kind of work, sort of identifying where we have the interest, and then we start the mapping. And we try to take people with expertise. I'm in Southwest Idaho. I've got an expertise in sedimentary and volcanic rocks. And then now that I've seen these rocks for the last 10 years, it's like, well, this is probably where I'm going to be staying, is mostly in the tertiary. Right. Reed Lewis, he's been mapping here for 30 years, I think. He's a belt expert, has been spending a lot of his time in the salmon country. So it just all depends on where our expertise is and where our strengths are and where we can flux into people. I've started a project in southeast Idaho. We got to work with a very renowned geologist in that region named Jim Coogan, who's did his thesis down there. And we're updating his maps full scale. We're trying to get him into USGS schemas. And that's been a big project. But sometimes we get to take advantage of the scientific expertise that we have so that we can sort of leverage the knowledge base that somebody's given us or somebody's available to share with us and get it into active hands. So like theses are hard to get to sometimes, but geologic maps, when we make them, they're free 100% of the time for download or for PDF.
Yeah, they're very available, right?
Yeah. So then we have another, degree of geologist. So Reed, my colleague Reed Lewis, is maybe mid-60s, and he's a paper and pencil guy. I'm 45. I use paper and pencil still because it's unbeatable. It's really hard to undo it. But
you're mapping on paper or pencil. You're not mapping with any tablets or anything like that. You're kind of doing old school mapping.
Some of the time. Yeah. So I definitely do a lot more nowadays with a tablet. The technology is really great. There's always holdbacks. There's always things that like sometimes it's getting the data out of the tablet into a form that you need. So all of our maps are produced in ArcGIS, which is a great program, big program, but sometimes it's a little bit cumbersome. It's and if you're older, it's harder to get you involved with that aspect. So for a guy like Reed, he's still doing paper and pencil, and Reed still does all of his maps on Mylar. So for those of you who don't know, Mylar is this plastic, semi-transparent paper. So you can see, let's see if we can get a better light here. So it's semi-transparent, and we will overlay, there we are. We will have these Mylar sheets that we overlay. We will print base maps onto topographic maps. Any sort of information we have, that was what I was showing you. Here's a cross section. And we still do a lot of our work on Mylar. So for Reed, it's 100% Mylar. For me, I only do my cross sections in Mylar. I do all of my own work digitally. So I collect my data digitally, but I still write down and I still hold my paper map because there's no batteries necessary for a paper.
Right. Yeah.
So
if you drop the paper, you could just pick it up hopefully, and if you drop the tablet, it could be dead. Yeah.
Yeah. The problem is when you're doing a creek crossing and you got your map and your tablet on both sides, and you're like, oh, I can't lose them both.
Yeah. Prioritization.
Yeah. So yeah, so we try to do whatever works for everybody, and that's been pretty good. I think as time comes on, we will probably have fewer and fewer people doing Mylar, and more of us doing digital capture and digital processing. So I do, like I said, I do all my own mapping on digital. If I might do some collecting and I might make ideas on the paper map. So I might draw where I think there's a fault structure or where I think there's some folds, and I'll use that as well to highlight. So this is more my problem than anyone else's. I'll highlight the property ownership. So a lot of my projects have been where people live, and in order to go look at the rocks, I have to get permission from the landowners, and for the most part, they've been really generous.
Yeah, what's your approach to that? Like, it's we're in the wild west. People are a little leery, and you go up and say, "Hey, I'm with the Idaho Survey and just mapping the geology. Can I walk across your 10-acre ranch and go look at that outcrop?" Like, how does that work for you?
That's exactly it. Yeah. Maybe I'll tell them. I was looking over in the distance and I saw some white ash, and I'd really like to get a couple samples of that for dating. Is there any chance I can get over there? And for the most part, people have been pretty great. I've been chased off a few times.
Yeah.
I'm one of those people that won't cross I don't cross a fence line unless I have permission.
Right.
But getting chased off at front doors, I'm like, holy cow.
Yeah.
I didn't expect so much anger.
Right.
But I do the thing where I go, hey, I'm gonna have to map this anyway, so you're just making my job a little more difficult. Meaning I'll have to use aerial photos and sort of.
You got to interpret it somehow. Even if you didn't even walk up to the outcrop, you have to put something on the map there.
Yeah. So especially in that Boise Weiser area, it's really, the land's really chopped up. But I'd say I have like a 99% success rate.
No, that's great.
The people have been really good, and the landowners have been really good about giving you access. And
well, they're interested in knowing what's on their property, and if you can like shed some light on that, it gets their interest piqued, I'm sure.
I always offer them a map. I said, when I'm done, I'll bring a map over and I'll drop it off and I'll explain to you what I saw. The majority of them are like, let me know if you find gold or oil.
Right, yeah.
And I always say, you'd be happy if I found aggregate, because
Yeah, that's where the real money is. Yeah.
yeah, you find gold or oil, and you got a problem. You got
Yeah. You got
big rigs everywhere,
yeah,
and
20 years till you see any production and profit from that.
exactly.
Yeah.
I said that aggregate though,
Yeah.
and
Start
they and
turning
they,
profit.
they they know the value in aggregate. So
Yeah.
oftentimes, sometimes what they'll do is they'll say, "Hey, I've got a question about this area over here. Do you know anything about that?" And I can give them
Yeah.
ideas about the rocks, or one of them wanted a couple people wanted to drill water wells, and they're like, "Can you tell me more about the water?" And I'm like, I can tell you something about the water. I can't guarantee I'm going to find it, but
Right.
you know, here's the data that I might use. So Idaho has like a repository online of its water wells. I use it all the time to help
Right.
with geology.
It's subsurface information for different
Yeah,
sites. Yeah.
yeah,
Helps you with your cross
and
sections.
and it's a bit of a crapshoot sometimes. You kind of open up the thing and it's like pink rock, and you're like, oh,
Yeah.
that's not going to be great.
No,
But
I know exactly what you're talking about. I did water for a couple years too, and it's like, the well logs sometimes are incredibly detailed, and you're like, this person knew their geology. They're
yeah,
like, coarse sandstone. You're like, thank you. And then other times it's like hard rock, soft rock, blue rock, brown rock. It's like redfish to bluefish.
yep.
It's like what am I going to do with this? Like, just I can't tell. I can't even tell what it is that you drilled through, and this is the only record I have.
Yeah, I always thought a good program would be to have every water drilling company has to bring on an undergrad intern to
To log,
describe
yeah,
to log the rocks. Yeah.
yeah.
And I was like, even there, you might get a little bit more consistency or a little bit more ideas of saying, hey, I think this is a granite,
Right. But
as
so
opposed
many
to
water
saying,
wells are just drilled by, well drillers who are incredibly hardworking people, some of which know their geology well, but some who don't, and it's a crapshoot, totally.
yep, yep. And sometimes you get that pink rock, and you go, actually, that's perfect because I'm in Huckleberry Tuff. And you're like,
Right.
pink rock's fine. I know what you're talking
Yeah.
about.
Now I know what the cheat code is for that.
Yes, yeah, yeah. When you're like drilling through black rock, black rock, black rock, pink rock, I'm like, oh, okay.
Yeah. Now I know what that is.
You
So
went through
how
the results.
so how long would you say it takes? Let's say you're tasked with like, one 7.5 minute quadrangle, which is how many square miles is that? Just so people have a rough idea.
Around
Like,
60, 64.
how, so how long? So that's just your project. That's Dennis doing the whole map pretty much on his own. Like, give us a time frame of like what that looks like and how long that can take. I mean,
So
obviously the terrain and the geology dictate it to some degree.
yeah, so the terrain and the geology extremely. I mean, they really dictate everything. So more often than not, we are mapping with other people, or we are mapping in collaboration with other people. Currently, I have a colleague in Boise who does the oil and gas work on the Payette fields down there, and he does the interpretation of the cross sections while I do the surface mapping, and then we combine our data together to make a map. Um, so in the Boise Weiser area, at this point I've been able to do most of it myself, but I have a couple of contractors that I hire out to come help me out there. One of them is a colleague of yours at College of
College of
Western
West,
Idaho.
yeah, Ander.
Yeah, Anders Sundell comes out. So it's great to have these college professors who have their summers off and can come rack up a few bucks and get to look at a few rocks and
Right.
share some field time with. And then I actually used to work with Sky Cooley. I think you interviewed him
Yeah.
recently.
Yep.
And Sky used to come down from Montana to do mapping with me. He would oftentimes tackle my quaternary stuff because he's a great geologist. He's a great geologist.
Yeah. Geomorphologies. He's good with that. Right.
Yeah, great with geomorphology. Has an eye, has a great eye for stuff, and a really, really smart guy. So, but lately I haven't had too many extra helpers. Reed's up in the salmon country where the mountains are
How,
this, and
how are
he's
his knees
got.
holding up?
I think his are still there. I think
Okay.
a couple of his mappers are getting long in the tooth
Yeah.
and weak in the knees. But I mean, I think Russ Burmister's 80 and he's still out here mapping.
Wow.
These guys who've seen these rocks for ages really know what they're doing, and you honestly can't replace them.
Yeah.
So he's got a team of about 3 to 5 guys who come out in the summers and help him with those maps. And then there's another guy out of another colleague of yours, Keegan Schmidt out of Lewis and Clark State
Right.
College in Lewiston, who does a lot of work for us. So like I said, these guys these people who are professors or instructors have some free time in that summer that really does make it helpful for us to get some extra help and extra eyes on the field. And a lot of times, you're coming into a new area, we get people trained up into what to look for and what to see and what rocks they need to be aware of or what's going to be tricky in this area. And then we trust geologists to be geologists and, want to go out and hike and bang on rocks.
Yeah, and then it's just up to them to interpret things.
We get granting. Most of our grant funding comes from the USGS on the state map grant. State map grant has like 3 parts to it. It's FedMap has 3 parts. There's federal mapping, state mapping, and then there's EdMap, which is students going out mapping.
Right.
So the state map is probably the biggest and sort of the strongest component. It's a really, really vital thing for the survey, but it's also vital just to the field. The USGS can't get out and map everywhere anymore, and the states are nimble enough and small enough to be able to get out there to produce good, high-quality work to sort of secure the future of mapping. So we get 1-year turnaround times. So we get 1 year, go out in the field. For us in Idaho, that field is May to November, maybe October.
Yeah, limited season, right?
Yeah, I don't go out past about October 10th when rifle season starts.
Right.
So
safety reasons, yeah.
Yeah. I'm willing to go out in bow season because I think you got to be close enough that you could see I'm a person. But with rifle season, I'm like, I don't take any chances.
It's not worth it, right?
So our field seasons last from May to October, and then from anywhere from basically September to December's analysis time. So we might be sending dates off we send Tim's dates off to Boise State. We send Argon dates to Oregon State. We've got laboratory across the border in Pullman that does a lot of XRF. Franklin Marshall's done a lot of chemistry for us. So we sort of spend the fall doing all of our analyses, and then we spend the last part of the fall into the early winter building our maps. So for Reed, it's sitting on a Mylar sheet. For me, it's sitting on GIS. And I don't know how much work you've done, but LiDAR has just made quaternary mapping.
Game changer, yeah.
Just so helpful. It's incredible. So, I'm working on getting ready for a map this summer, and I've started doing the quaternary mapping where I'm going to get out ahead of myself. So when I get in the field, I can double check on all these sites to see if my interpretations were close or somewhat close or not even just whiffed big time.
So you only have a year to do each map. So even if Reed or you have like this incredibly rugged, super geologically complex 24,000 quadrangle, it's got to be done in a year, and you've got to figure out like, well, I need to pull in some manpower for this, or I've got to just log the time to get it done. So I didn't know it was on a timetable like that.
Yeah, it's on a 1-year turnaround. So what we end up doing is we try to produce a draft map. I'll pull one up here in a second. We try to pull up a draft map, something that's close to being done, and so here's one of our draft maps in the Preston area.
Mm-hmm.
And it's got the geologic map over here, your correlation of map units up here, and then map rock descriptions down the front here. This is pretty close to a complete map. However, we sometimes have that thing where you start mapping the next year and you go, oh no, I completely missed this zone to the south.
Right.
I'm mapping to the south and I got to realize, oh no, I made an error in here. So we're given 1 year between turning in the draft and having a published map. So at the Geological Survey, we try to get the map completely done in 1 year. And then you're given a year to
stage, right?
A year to sort of like modify some of your interpretations and get it out. One of the goals is that first year is to get it as close to done as possible.
Right.
And so our survey's goal is to cover the state in 24K maps. We have probably 41% of the state covered.
It's a big
And,
state. Yeah, it's a lot.
and it's
That's
not growing
that's job
fast.
security for you.
That's right. That's right. So we do these 24K maps, and then one of the things we sort of do at the end is to sort of do a compilation of the maps and sort of update what you've learned. So in this Weiser area, I did 16 quadrangles, and I just produced the 100K, or sorry, half of 100K, which we're mapping at a scale of 1 to 75. So I'm going to show you that real quick.
Okay. Yeah, go ahead and share. And while you're pulling that up, during that draft stage, is there other geologists? Do you guys go out and do field reviews of your map and like, let's go look at the problem areas in the map and get some other eyes on it and some other perspectives? Does that happen?
When I worked at the Virginia Geological Survey, we did that, and it was a pretty helpful process to be able to show what you've done and how. Are you all seeing that map?
I see a cool landscape picture of Death Valley or something with
Yeah, I
the
don't think that
sunset.
worked.
Okay.
Okay, hang on one second.
No, you're good.
Um, so when I worked at the Virginia Geological Survey, they did a field map review, but every year I'm producing 2 to 3 maps. Reed's producing 3 to 4 maps, and then I might have 2 more maps from last year and 2 more maps from the year before that we're trying to get out the door. So if we're trying to show 6 maps, 7 maps, it's almost impossible to
It's too
try to
fast of
get
a pace. Yeah.
a review out there. Do you remember that old scene in I Love Lucy, where her and Ethel are sitting at the chocolate factory, and it's all the chocolates are zooming by, and they're like, "Oh, this is great!
Yeah.
We're gonna put one piece of chocolate in the box, and then we're gonna move this over, and then it starts going a little faster and a little faster.
Right.
And
And
all
then
of a
they're just
sudden,
flying.
throwing
Yeah.
chocolates. That's how it feels here. So like you're on this conveyor belt of just constantly moving maps.
Right.
And a couple of years ago, I got caught up in some interpretation issues, and we had an external geologist who wanted to bring some information in, and we were waiting for a couple of years, and all of a sudden it was like, oh no, there's 8 maps backlog that we didn't get out.
Yeah.
So now you're sort of getting unpaid work. You're not unpaid, sorry. It's unfunded work to get these publications out. But it's so valuable. That's what we need. So we, had this major push to get these 8 maps going and get them moving again that we're hoping. So the USGS recently started this 1 year to deliverable and then 1 year to publication.
Right.
I'm really hoping that will solve the problem of I just have some tie-ins that I want to fix. It forces you to do it because if you don't turn that thing around in a year, you don't get funding for the next year. So they put an incentive on it to make it work and it's effective. So it keeps the geologist from being like, I just need to change a few more things, and I think that should be helpful for us.
Yeah, because you could sit there and look at a map and nitpick it for 30 years. You could sit there and say, well, this contact's off a little bit, and like at some point, good enough is good enough, and you roll it out there and get it out in the public.
Yes, that's correct. And that's the thing is I always try to suggest that when I see we got Inception going on.
Yeah, right.
When at some point you realize the mapping I did here was last done at 1 to 250K scale 50 or 40 years ago. So
Yeah.
even when I produce something that's got something wrong on it, it's better than it was because you've updated and you've created new ideas. So this is the Weiser West. So this is half of 100K.
Hold on, I'm not seeing it, Dennis. I'm just
Oh,
seeing
we're still not up.
the Riverside thing.
Oh no.
Sorry.
Okay. Nope. That's not your problem.
Well, yeah, I'm throwing this new software at you that I haven't really totally used.
Well, the screen share seems to have a funny thing to it that.
You should be able to.
There you go. This will work.
Yeah, use screen. There you go. Okay, now Now I see the Weiser map. Yep.
Okay, so here's that 100. Here's the 75K, which is half of 100K, and this was essentially over. Let's see, 12 years worth of mapping. That we started in this central area right here, and I was so confused starting off. I thought there were 3 volcanic units and 1 sedimentary unit, and 12 years later I realized there's 13 volcanic units and 4 sedimentary units.
Right.
So you gain so much knowledge and learn so much that rather than keeping that old data as the key, we like to recreate these half 100Ks or 100Ks. It's still 24K scale, so the map, it's a little tight, it's a little the quaternion is a little hard to see here, but this is much more of a visualization that tries to let you know we've updated this. We've learned a lot, and it's so different than what we started with in the 24K.
Right.
And then one of the things that we're now doing is, as we produce this, it will have a GIS available. So people who want to use the paper map can still download the paper map for free, and people who are new, updated, technology savvy people can grab these maps and use them digitally to update their work. This area's got a mercury mine with a small gold prospect in it. There's a geothermal field in here. So a couple companies that I've talked to have already used this data set to look at stuff and get ideas about what they want to do in the future or where these rocks are. So the survey is having to adapt to the times and the needs of the world.
But what's impressive to me, sorry to interrupt, is this, you're tasked with doing this quadrangle. You're kind of dropping yourself into this location. You don't have any or very many other mappers with you. So you don't have a lot of brains to bounce ideas off when you're trying to figure out how many volcanic units and sedimentary units you've got. You got whatever publications are out there, which in this part of Idaho might be kind of, minimal. And then you've got to piece it all together. So it's a really impressive feat to put this together in a year. I'm just amazed.
These volcanic rocks were really interesting. So this was a field mapped by James Fitzgerald in 1979. And the story about James Fitzgerald is, these volcanic rocks up here to the right.
What color are they? Which color are you looking at?
So they're the browns, purples, and pinks.
Okay.
And James Fitzgerald, he's one of these people I think was born to be a geologist. He's got it in his blood. He was deeply in love with the stuff, and he mapped this area. It's actually way bigger than this. Goes up on towards Riggins, goes down into just north of Boise. Just covered this a massive amount of area. And in 1980, he heard the Mount St. Helens eruption was going to go off, so he packed up his bags and went down there to watch it with a friend and died in the eruption.
Oh my gosh, wow.
So his buddies got together 2 years later and finished his PhD for him. So there's a posthumous PhD based on this. And this is where I started. And like I said, there was 3 volcanic units. This was back in the 80s when the Columbia River basalts were like the hottest topic there could be. So I get his data sets, I have his field notebooks, I have his field maps, and I'm sort of getting to use that stuff to put the story back together. And as I start playing with his data, I realize the time that he was mapping, we hadn't even built a cohesive chemical breakdown for rocks. So he thought these were all basalts, and some work in the early 90s, somebody pulled out the basalts and said, these don't belong to Columbia River basalts, they're a calc-alkaline series, which indicates they probably come from a different source than the Columbia River basalts, which are autolitic.
Were they the same age as Columbia River basalts or different age?
Same time frame. Okay. So, in fact, the dark orange, so the dark rocks up here in this upper part are Columbia River basalt, as are the, as are these blue rocks up here in the corner. Those are some of them Naha, and the orangish ones are Grand Ronde. Okay. And then down here, we run back into more Grand Ronde, and there's some Steens down here in the farther east towards Emmett. Wow. So this is Columbia River time. But on top of the Columbia River basalt is this other sequence of calc-alkaline rocks, which sort of indicate that they spent more time probably in vaccination and absorbing some other country rock that have a signature. So I get to this field and I start looking at it and I go, these are complete. I don't know much about them. So I find something like 4 other types of andesites. I identify 6 more rhyolites. And
Wow.
what's strange about this is the andesites are black, the rhyolites are black, the basalts are black.
Like weathered black, or their real color is black?
Real color is black.
Whoa, that's trippy.
So I've got one right here. So this is one of the rhyolites in the field.
Yeah, it looks like a basalt on the webcam.
And here's another rhyolite from the field.
Are they vitropheres? Are they like glassy at all, or that's actually?
So that's the blackness in it. It's a little bit glassy. Now, obviously, they're 15 million years old, so the glass is not, too
Right.
terribly glassy anymore.
Right.
They really have just a fine matrix and ground mass, and then they have a lot of glass component. But the minerals that make up the rocks are darn near the same minerals that make up the basalts. So I think we're looking at a crystal fractionation where some of the more mafic minerals are falling out, and these plagioclase are coming to the top
Right.
and erupting as these rhyolites. Or actually, I think I should say they're erupting earlier. I think the rhyolites are happening earlier than the basalts, and I've got a few argon dates that confirm the rhyolites are earlier than these basalts that come in and act like flood basalts. So they act like Columbia River basalts, but they seem to be of a different sort and a different nature. Obviously, they don't have nearly the lateral extension of the Columbia River basalts.
Right.
But there's 2 other fields like this. So there's the Powder River volcanics a little bit farther west into Oregon, and then the Strawberry volcanics a little bit farther west of that, just near the Strawberry Mountains in Oregon, in eastern Oregon. So, I then get to have this cool project of finding these new, not finding them, but identifying these new andesites and rhyolites and saying, what's happening here? What do they do and why are they different? And then as I start talking to Oregon geologists, they say, oh, that piques our interest. And we end up being able to develop really cool projects that I can't necessarily follow up on because I'm on that conveyor belt. But
yeah. You hand them off to someone else.
Exactly. As faculty comes in, there's people all over going, hey, I want to do some research. I got a project. I got project ideas. And I'm like, I got a ton.
Yeah.
So
well, that's because you're the boots on the ground guy, walking all over this place, looking at these relationships and digging in more detail than most people have. And so you're coming up with all these ideas and things of further study.
Yeah, and I think that's one of the things that the mappers do that I don't. So oftentimes when you meet young PhDs who come in and they're like, everyone can map, and I'm like, but not everyone does.
Yeah.
So every PhD you ever see, you'll have or new projects you see, they're always like, I did mapping, and then they have this little box in there that shows the map, and I'm
like 1 square mile or less. Yeah.
Yeah, this is a figure, not quite a map.
Right. Yeah, especially by your standards.
Yeah, and I sort of go, we do the. I sort of consider the base science, right? There's the geologic laws, the laws of superposition. I'm not doing that kind of base, but any geologist who's going to come into this field, the first thing they're going to do is come to our website and download these maps.
Yep.
Because it tells them everything they need to know about what they're walking into.
Right. Well, the maps are our most fundamental data set. Like it's almost like a equation to a physicist or something. Like the geologic maps is what we know about this portion of the Earth's surface and maybe even the subsurface. And so it all stops, begins and ends with those maps.
Yeah, that's correct. And I can't quit selling the value of like how much we need mapping and why it's really important. Because yeah, it's that base. It's that thing that we all start with. Every geologist who's ever started a project, who's ever gone to a new area, first thing they do is download the maps of the area.
Right.
And I now that I've done this enough, I go, I love looking at maps and being like, what was this guy looking for?
Right, but someone has to be the first brave person to like go into that space and make the first map, which is kind of like you and Reed now to some degree is. It's easy for us to come in an armchair quarterback and be like, well, what was he thinking here? And I would interpret this differently. But you guys are like putting something on the table that we can start from.
Well, and you get to that area and you go, what was that person thinking? And you realize they were on horseback and they you obviously can't go to every spot. So you
And
have
they
to
didn't
make
have LiDAR, yeah, or whatever,
you have to
right?
make assumptions and interpretations, and you kind of go, that's okay. I'm totally fine that you didn't get over here. I'll get over there and I'll
Right.
cover it. I don't know if you've in your part of the country you have that Oriole and Platte map. So
Yeah.
that's from Preston to LaBarge, Wyoming. And this that's I think it's 1 to 250K scale, and I want to say it's 200 miles by 100
Oh,
miles.
yeah. It's like just,
It's amazing.
yeah,
And
the
those
details are incredible.
I must have taken them 10 years to do that because I think they weren't on horseback, but they might have been for some of this field area because it's just remarkable what they produced.
Yeah. Those big ones are just incredible, just getting that detail down. Because you got to cover so much ground. Like one
Yeah,
quadrangle, like you just showed with the Weezer one, like that blows my mind. I'm like, holy cow, that would take, it would take most people like many years. And the fact that they can cover those big ones, without the aerial imagery and some of the other things we
yep,
use, like that's just looking around and like spotting scopes and
yeah.
crazy.
Or when you see these guys who did reconnaissance maps, so they basically only did the mapping through aerial photos. You're like, this is impressive.
Yeah, yeah. They never even went there, but they sat in an office somewhere and interpreted it all. That's like the
That's
other end of the
correct.
spectrum.
That's correct. I'm always like,
Crazy.
that's so cool.
Jeez. So what's like a for Dennis? What's like a typical work week for you? Because it probably varies quite a bit, but is it kind of more of the seasonal thing, like you said, where like when it's field season, you're just out there a lot and then bouncing back and forth?
So yeah, I've got a family at home. I got two young kids. So
Right.
when my field season hits, I'm like, I could do about 2 weeks in the field, but I
Yeah.
got to get home and spending time with the family is important. So I really do like this job because it gives me some field time. But I spend all day in the office from October to May. So this is my time for map production. So um, right now, let's see. Right now, I've got like 4 projects sort of hanging. There's that Weezer map that I just showed you. I've got to work on the booklet, so I got to describe all the rocks
Yeah.
formation or all the units that I separated out. I've got maybe 75% of that done. Then I've got to bring in some photos and some illustrations that'll help interpret what I saw and how I saw it. So that'll take me another month or two, and it's just a lot of writing, and it's a lot of checking, and it's a lot of revising things that you wrote 2 days ago. Um, then, along with that with that map, I've got to publish the geochemistry data sets. So, James Fitzgerald's work from 1979, I was able to go to the lab at Washington State, and they still had the beads, so they reran 380 of his geochemistry beads for trace elements. So now I need to take that data set, sort of interpret what I think is going on with the points that I've been to, publish that, as well as the chemistry set that I made for this data set,
Oh
so
wow.
that when somebody looks at this map, they can download the chemistry that goes with it. I'll also have to work on the age correlation work that I did. So,
Yeah.
you're making figures, you're making
I mean,
publications.
really what you do every year, Dennis, is 1 to 4 master's theses. Like I mean, really, if you think about it, like, I mean, the old school master's thesis was essentially mapping some area, describing the rocks and the structures, getting the ages, and putting it all together in map, cross-section, report format. And you're cranking that out like, 3 or 4 of those a year. That's pretty impressive. It boggles my mind just thinking about it.
Yeah, and I'm even more impressed with somebody like Reed Lewis, who's doing the same thing as well as managing 4 other grants. So
Yeah.
he's got all these projects going on. I'm like, I don't know where he finds the time because I'm running low on time myself.
Yeah. No, it's really incredible.
And sometimes you get a map that the geologic story isn't as compelling or powerful as some of the others, but some of these ones that that 100K, that's such a cool story to have once you get the whole thing together.
Yeah.
And yeah, there's a PhD somewhere in there, I'm sure.
Right. Do you ever feel like when you get one of these done, because I mean, you imagine you're just like, you're doing all the work, you're cranking out the map, it gets published, but you don't get any of the fanfare. It's not like I mean, it goes out there. Maybe there's a press release, and maybe you hear from one or two geologists that actually look at the thing, but I don't know how many eyes you get much feedback from the public or other people that like, wow, this was a great map you put together. How much feedback do you get from these as you're just cranking out the conveyor belt?
Yeah, very little. Yeah,
Right.
and like imagine that scene with Lucy and Ethel, and like the boss coming in and being like, "Hey, I want to give you guys an award," and you're like, "I'm too busy."
Right. I mean, it's just such a contrast with what your wife Chelsea's doing, where they're putting out these fabulous books and illustrations that hundreds, if not thousands, of people are consuming and buying within the first year. They're in bookstores, people are seeing them. But geologic maps, like the ones you guys make at the IGS, they're on your website. They're available through your store. They're not at the local Barnes and Noble sitting on the shelf. They're not hanging on the walls. They're harder to get to, even though they are public access. And so, I guess if you were looking for adulations, you'd be quite daunted by the job, but that's not what you're doing it for.
No, and yeah, I think you're just a humble servant, just doing the
Right.
job.
Yep.
But part of it is also like I get to go in the field, and
Yeah.
that's its own reward.
Yeah, that's true. That's your payoff right there. Is you get to go outside and the problem solving, right? Like you're the first one in many of these locations to spend that much time in these areas. So you're like the first crime scene detective on the case, so to speak. And I think that's got its own like kind of thrill to it.
Yeah, I recently I'm starting a project in Southeast, so it's part of that Preston project, and
Right.
I'm starting a quad called the Nounan Quad, and it's got a really fascinating um, tertiary age problem in there that I can't. I've started like poking into and going, oh, there's some really interesting rocks in here that I don't exactly know what they're doing. And back in the day, they mapped them as all tertiary. They said, oh, this is all tertiary
Yeah.
salt lake formation, and I go, I don't think it is.
Yeah.
And then you read a paper and somebody says, oh, there's quaternary folding here, and I go, there's no quaternary folding. Now you can see the fold, and you're like, okay, I think there is a fold here in this tertiary age rock, but it might be like a drag fold. So it might be that the basin's dropping down over here and
Right.
pulling the formation sort of across.
Like a drape fold almost. Yeah.
Yeah, yeah, and it's like, well, that's a different interpretation than a fold in the quaternary.
Right. That
But
implies compression. Right. Yeah.
exactly, exactly. So I go, oh, that's still an interesting story. And in between these like tertiary rocks, you have Precambrian and Triassic rocks that sort of poke up in the middle, and you're like, well, how did they get there? What are they doing there?
Yeah. What
That'll be a
exposed
fun
those?
story to tell.
Yeah, and gosh, the Salt Lake Formation such a garbage bag term, and like it's anything they couldn't figure from like Eocene to Quaternary just like got dumped in there, all
Yeah.
sorts of rock types and yeah,
What I'd like to do, like, so it's the same with the Western Snake River Plain. So like the sedimentary rocks that are featured in these small basins, is I kind of wish that we just put a timestamp on them. We'd say, oh, this is Miocene, and then you'd say this is the Georgetown member of the Miocene deposits. And then you
yeah,
describe the deposits, how they appear. So there's like an alluvial fan of gravel up there, way up high in this pitch. And then as you head towards the west side, you're like, oh, well, here's a whole bunch of lake sediments. They're the
right,
same
yeah,
time. So this must be the Georgetown Basin sediments. And I wish we kind of broke them up into smaller sections, because I think we still try to use the old school geologic terms for large basins, or for the Cretaceous and the Jurassic, to describe much smaller features in the tertiary. And I kind of go,
hmm
we probably should have done something different for the
yeah,
tertiary.
just not the ideal model for those kind of systems, basically.
Yeah,
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 like the latter, they're not as laterally continuous. There's these facies changes laterally or something,
exactly.
and so you need like a better
Exactly. And
map.
sometimes when you're mapping, the garbage can aspect of the Salt Lake is helpful.
That's true. No, I mean, yeah, if I'm mapping, it's like great. I can just shove it in there. That all takes care of this chunk of the map, right? But then for all of
Yeah,
us using the map, it's confusing and frustrating because there's so many lithologies and
right.
things going on in that unit.
Or the second you try to do a compilation where you're stitching these
Yeah,
salt lakes
it
together,
doesn't
you
match
go,
up.
these don't make sense at all. What were we
Jeez, it's
thinking?
crazy.
Yeah.
Sheesh. Well, to wrap up, this has been really fun, Dennis, and I feel like we could maybe do a part two somewhere down the road and chat. But maybe give us your sort of big takeaway, or maybe your sales pitch on like why maybe future students or others might want to get involved in geologic mapping, or just your your philosophical view on this part of geology and why it's important.
Yeah, so I consider it the sort of the humble mapper. I've used the term already before, but like, yeah, there's not a lot of like reward or adulation for this work, but the work in itself is so redeeming. And knowing that this map that I made, so this Weezer 75K, it'll stand for 50 years as the scientific record of this place. It's such a valuable piece of information that we have. I have a personal philosophy, which I believe I consider myself a pragmatic optimist. Um, I try not to get down too much. I try to keep things positive, and I sort of look forward. Like, there's always something to be found. So sometimes you might grab a map and go, sorry, I get assigned an area and I go, it's going to be a boring one.
Yeah.
And you start mapping and there you go, what's kind of interesting is how these hills shape and how these hills form. I wonder what's happening here. And you start tying in some of the sort of like lineaments you might find or some of the features you're finding on the surface. And all of a sudden, pull a few strings and all of a sudden you have a neat little story that plays out. I've done it with some gravels in the area. I've done it with some the volcanics was just a fascinating thing to keep playing with. And you run into these roadblocks. I took samples to Boise State and they couldn't get enough zircons out of it, or they couldn't find good enough zircons to date some of these things. And I had run some of them for argon, and they came back positive. And then I started to figure out DZ work. And I'm not an expert in any of these fields. I'm not an expert volcanologist. I'm not a geochronologist. I'm not a sedimentary person.
Right.
But in some ways, you get to do it all,
Yeah.
and you get to play in it all. Yeah, I've been trying to describe detrital zircons to a colleague, where I'm like, oh, these detrital zircons are telling me a very important age piece that tells me that the deposition must have happened before this time. So there's your maximum depositional age, and this detrital zircon's giving me the fingerprint of the provenance of this sample. So they're almost the exact same data sets, but they're telling me two different things, and I kind of find that fascinating.
Yeah.
And you get a really good opportunity to put your hands into a lot of fields. And if you work around people like Reed Lewis, who is a fountain of knowledge and kind as can be, and willing to share with you everything he knows, you have the opportunity to gain so much from the people around you who've seen so many rocks and witnessed so many things. And he can tell you when you saw that fault scarp from the Chalice earthquake in 1983, he's like, you can see how quickly that erodes away. And it's fascinating to be with these people who've been doing this for a long time and seen so much. Take advantage of all the people around you and the things they're willing to share, and be willing to share that equally back to people. It pays off so much. And being in the geologic world, we're small. It's a small, tight community, but I don't necessarily know that I was going to go here when I was a youngster, and now I'm like, I can't imagine the world outside of it. These geologists are great to work with.
Yeah, no, it seems like it worked out great for you. You're obviously in your element and psyched, and I think your passion and your energy and your love of what you're doing just totally comes through. So I think that's a great note to end on. So thanks so much, Dennis, for spending some time sharing a little bit about yourself and what you do with folks. I think people will find it interesting to learn more about how geologic mapping works and kind of like just your career. So thanks so much, Dennis. Appreciate it.
Yeah, thanks a lot, Sean. Appreciate your time too.
Okay, take care.
All right, you too.